Has this ever happened to you?
My child will start vomiting, crying, and he keeps on moving his head. I don't know what's going on.
We introduce to you the newest breakthrough in mitochondrial DNA editing. Zinc will revolutionize the way we treat mitochondrial genetic diseases.
As a medical geneticist, I research and diagnose conditions for patients. This child right here has poor head control. He continuously cries, and he vomits. We have tried to determine what's the cause of this disease, but we have not figured out anything yet, except for Leigh syndrome. So Leigh syndrome is caused by a mutation in mitochondrial DNA at the gene MTAP6. MTAP6 creates a subunit of the molecule ATP. Without this, ATP is not made properly, and thus the body's cells cannot function properly. So Leigh syndrome is a disease that causes progressive mental and muscle deterioration. So, as you can see, this is a healthy child with Leigh syndrome. For the first year or so, he'll be growing normally. But after a while, his inability to produce ATP will cause muscle growth. So essentially, he'll become extremely bony and lose lots of mental function. Currently, the only treatment is the administration of vitamin B1 and sodium bicarbonate in order to slow the progression of this disease. But however, since it is a genetic disease, it cannot be stopped. Now we can use that to determine a cure for that disease. Because this child has grown, we cannot save him. The only way we can save a child is in the embryonic stage. So we will have to use our retrovirus on the embryos. Some might consider this wrong and unethical, but we believe that
The benefits outweigh the risk.
As a biomedical engineer, I have engineered some zinc-finger nucleases. What they do is they get inserted into a cell with the lentivirus right here, along with the chromosome or the correct gene for fixing Leigh syndrome. Then the fingers bind to codons or 3 base pairs of the DNA, and where they intersect, they cut out of the genome, the mitochondrial DNA. Then, since it's a double-stranded break, the DNA automatically wants to repair itself. But because we brought in the correct gene with the lentivirus, it inserts the correct gene into the DNA, and so the MT-ATP6 gene now works, and the child can make ATP properly.
So lentiviruses are subtypes of retroviruses. The reason why we picked a lentivirus is because they're capable of infecting dividing and non-dividing cells, whereas retroviruses aren't capable of infecting non-dividing cells and only able to affect dividing cells.
However, since we are using a retrovirus, there is a chance for an immune response, but we can edit the proteins on the surface of the virus such that there is a lower chance of this happening. This will cause the immune system to have a lower chance of recognizing this virus as a virus.
Hello everyone, I'm Mr. Rashid. I'm the founder, the sponsor of this project right here. And when these guys, and let me tell you, when these 3 guys came to me with these zinc finger nucleases, I was blown out of the water. This is game-changing stuff, and I really believe in this. And I believe these 3 guys know what they're talking about and are able to do what needs to be done. That's all I had to say. I just wanted to stop in and make sure you guys are aware that I believe these people, and you should too.
You might be saying, why didn't they use CRISPR? However, our resident medical geneticist, Chris, has the answer to this question.
As a microbiologist, I decided that it is best that we use zinc finger nucleases over CRISPR because zinc finger nucleases is specified towards mitochondrial DNA. So instead of using CRISPR, which is not as specified on mitochondrial DNA, Zinc finger, we would use a virus, a retrovirus, the lentivirus, which we can use to specify specifically on Leah syndrome.
Thanks for watching, and I hope you buy our new product Zinced, coming to a hospital